Hello everyone, welcome to lesson 7-6, slope and similar triangles. Let's jump right into our real world link. Physics. In an experiment using a coiled spring toy, Zoe and Jack determined they needed to raise one side of a 5-foot board 3 feet for the toy to move. So they have a 5-foot board and they must raise it 3 feet so that the coil can move. And you see it here. Here's your 5-foot board and they have to raise it 3 feet. So it looks over here like we have our 90-degree angle. We have one leg, another leg, and our hypotenuse. So if we were to use Pythagorean Theorem, we can solve for this leg, right? We would have a squared plus b squared equals c squared. Find the slope of the board. Hint, use Pythagorean Theorem, as we just did for a second there, to find how far the end of the board is from the books. So we have to find how far the end of the board is from the books. So we would use a squared plus b squared equals c squared. We know that we don't have the a squared at the bottom, but we do have the b squared, so it's our 3 squared, okay? And that equals 5 squared, right? Because that's our hypotenuse right there, as you can see. And it's still simply a squared, right? So it's a squared plus 3 squared equals. So now we have to isolate the a, okay? But let's actually turn these numbers into what they are. This would be 9 because it's 3 times 3, and this is 25. So I will simply write that up here now, okay? So I have a squared plus 9 equals 25. I'm going to isolate, so I will isolate by inverting, taking my 9 over to the other side, and it becomes minus 9. It's gone from here, and now I have a squared equals 25 minus 9 is 16. And now I have to square off the square that I have there, so I will square root it. Get rid of the 2 and square root the 16, and that gives me a equals 4. So I simply have 4 right there. Okay? So now they want us to find the slope. Well, how do we find the slope to all this? We take what we have right now, what we know. I'm going to erase all this here. Okay? And we're going to take, we know that this is 4, right here, 4 feet, right? So I have a run of 4, and I have a rise of 3. Remember rise over run, x over y equals our slope, right? Equals m. So our slope is our rise, we said it's 3, and our run is 4. Right? Our rise is 3 and our run is 4. And there is our slope right there. But you will notice that it's also a negative slope, right? So one of these two has to be negative, and we can make that the 3 if we want. The 3 is a negative because it's dropping 3 and writing 4 in the positive direction, unless we're counting this way. So one of the two has to be negative. I've chosen the 3 to be the negative. Second part, number 1. Draw the triangle formed by A. Point A is 0, 2. Okay, I'll just go right ahead and do that. 0, 2 is right here. Okay. I went 0 and 2, just up. 0, 4. Okay, so now 0 all the way up to 4. Okay, right there. And 3, 4. 3 this way and 4 up right there. Looks like it's going to give me a right angle triangle. Okay, so now I have to draw the triangle, and it's asking us what kind of triangle did you draw. Well, you can see right there that it's a right angle, right? There's my right angle right there, so it's a right angle triangle. And now they're asking us to draw the triangle formed by D 6-6, F 6-8, and G 9-8. How is triangle DFG related to triangle ABC? I should label this first. So let me zoom in and label it. And let's now find these coordinates. D, 6 and 6, so go to 6, all the way up to 6 is right there, okay? And then I have 6 and 8, right there. And then I have 9 and 8. 9 and 8, which doesn't even fit in here. 9 and 8, right there at the very top corner, okay? Almost top corner. So there's my other triangle. I'm going to go ahead now and draw my lines. So then, how are they related? Oh, I forgot to label it. It's D down here, F, and G. Okay. So they're asking us how they're related. Well, I can see that they both have a rise of 2 and a run of 3. So they both make a right angle triangle with the same transversal line. So what I can say is that they are congruent. They are congruent. So draw the triangle formed by A02, K06, and D66. Okay, let's do that triangle now. So I went ahead and I marked them. 02, there's my 02. 06, there's my 06, and 66. 66. Okay, so I have another right angle triangle here. I'll draw that. There we go. So I did that, and what do we know about them? How are they related? How is this green triangle here, which is now going to be triangle A, K, D, right? So we really only have one more label to make, K right there. A, K, D. How are they related? Well, I can tell that they are similar because even though their lengths are different, they still have the same angles. You see, they still have a 90-degree angle. They both start at the same. They both share this vertex, okay, and they both meet at this vertex here. So this one had a rise. The smaller one had a rise of 2. The green one has a large of 4. This one had a run of 3, and this one has a run of 6. So it's double the size, right? So we have a factor of 2. Okay, so we can just simply say they are similar. As you can see right there, they are similar. Okay, let's answer question 4. We can move on. What is true about the hypotenuse on the 3 triangles in steps 1, 2, and 3? Well, what is true about the hypotenuse? Right here, this is the hypotenuse to each one of those triangles. The first triangle, the second triangle, and then the third triangle. Well, they all fall in the same line, don't they? So they all share the same transversal line. They all have the same hypotenuse. Similar triangles and the coordinate plane. In the figure shown, triangle ABC and triangle BDE are sloped triangles. Sloped triangles are similar. We simply follow the same slope. Okay, and you can see here, angle BAC, again we're looking at angle A, is similar to angle DBE. So here we're looking at angle A is similar to angle B. We always look at the angles in the middle, right? Angle ACB is similar to angle BED, and so triangle, because we have 2 given angles that are similar or are congruent, then we have a similar triangle. Triangle ABC is similar to triangle BDE. You can use the properties of similar triangles to show the ratios of the rise to the run for each right triangle are equal. So you can show the ratios, that they are equal. Okay, so 2 to 3, an increase of 50%, 3 to 6. Another increase, no, I did that wrong. 2 to 3, 4 to 6, an increase of 50%. We also have to practice writing proportions or writing ratios in order to find numeric values. So write a proportion, as you see here. Write a proportion comparing the rise to the run for each of the similar slope triangles shown above. Then find the numeric value. So here's what we were saying. line AC and line BE of the same triangle will are equal to line BC and line DE. Okay, we do a cross product where we multiply this line, this measurement, with this line, as you can see here, and this line with this line, as you can see here, so that we can solve. So now that we're multiplying that, okay, we have ACDE being multiplied with BCDE, and BC is being multiplied with BCDE. Okay, so what do we get? We get AC, BC, BE, DE, which is 6 over 4, which is the same thing as saying 2 over 4. Okay, so lines AC over BC equals line BE over DE, or 6 over 3 is equal to 4 over 2. I believe you can do this on your own. Please read through it, graph the following coordinates to draw two triangles that share the same slope or same hypotenuse. Okay? Pause the video and try it on your own now. Okay, I hope you're ready to check. Graph triangle MNO with vertices M, 3, 1. So I will go to 3, 1 right there. Okay, that's M. N, 1, 10. 1, 0, 1, 0 right there. Okay, so it doesn't go up. And 3, 0. 1, 2, 3, 0 right there. That's a very small triangle. So I have M, N, O. Okay, then write a proportion comparing the rise to the run for each of the similar slope triangles and find a numeric value. So then we can just write a proportion. Let's say I wanted to go from a rise of 1 to a rise, I don't know, of 3. I guess we can go 3 times larger, right? We could say that this is half the size, or let's see here. I could go with a proportion of triple the size. Triple the size, but I have to remember to keep the same hypotenuse, okay? So if this becomes triple, I could do 1, 2, 3, or I could even go down 1, right? Where I could do, for example, that could be one of my coordinates, and that could be another one of my coordinates, right there, okay? Simply because I'm trying to follow the hypotenuse, so I would go 1, 2, 1. You see how it went here? 1, 2, 1, 1, 2, 1. So I want to keep the same slope, and if I were to put it there, okay, then I would have to put it down here, okay, because I'm going 1, 2, 3. You see that? So I want to go 3 down from this point. So if this tripled, this also must triple. Okay, so here I have 2, so I need at least 6 down here, and I can start counting 1, 2, 3, 4, 5, 6, and that would keep right with my hypotenuse, right? So I'll put the other point there. Now I have to come up with coordinates, right? So that's essentially the logic as to why the triangle would have to be like this, so that we cannot follow the hypotenuse. But as you can see here, they've also provided the exact same coordinates, right? You see that we have 5, 2, so we go 5, 2, and that's P, okay? We have Q at -1, -1, okay? Q. And we also have 5 and -1. We go all the way to 5 and -1. And that one is R. Okay? So I'll draw that triangle. And you can see that we are sharing the same hypotenuse with the triangle. Okay? So what could we say here? We can say that line MO, okay? MO right here. The little line in there. Okay? Line MO is equal to line PR, right? Right there, as you can see. Okay, and line NO line 8, oh, sorry, no, not congruent, there's no congruency. Line 8 and O right here is equal to QR right there. QR, which is all equal to, the top is 1s, okay? The bottom is 2. And the way I got 1 over 2 is simple. I'll show you. I'll replace my numbers. MO is 1, right? As you can see here, it's only 1. And that means PR is 3, right? Is 3. PR is 3. And O is 2. You can see it here if you haven't counted. And O is 1, 2. And QR is 6. Right? You can count the units right there, the squares. And when we cross multiply, okay, which really we don't even have to, because we can see that it's a half, this is a half, and it's going to also be a half. Okay? Similar triangles and slope. Words. The ratio of the rise to the run of two sloped triangles formed by a line is equal to the slope of the line. It makes sense. So we have 2 points on the line here, okay? We have 4 and 2 as well as 1 and 8. So we have to look for the difference of these two lines, between these two lines. And I see that I have a rise from this point to this point. I have a rise of 1, 2, 3, 4, 5, 6, which makes sense, right? Because 8 minus 2 is 6. So I have a rise of 6 and a run, the difference of runs from here to here. What is the difference? I have 1, 2, 3, right? So it's 6, rise of 6 with a run of 3. So it's 6. My slope is rise over run, which would be 6 over 3, which is just the same as saying 2, because if you divide the top divided by the bottom, you get a rise of 2. But notice that it's sloping this way. It's not going upward, it's going down. So really, when we do our run, we move run this way and then down. So this is actually a negative 2 because it's a negative slope. So we would write it as equals negative 2, not 2. We can see here that they've done the same. Now, make sure that, let me just zoom in and explain this a little bit better right here. Because we are moving down on a downward, we can see that one of the two values, either the x or the y, is going to have to be a negative. Right? In this case, because we're moving this way positively, our x is going to still be positive, while our rise, because it's going down, is going to be negative. Okay? So essentially, or it could work the other way around as well, because we could be moving in this direction, right? In that direction, where we're moving negatively with the x, but positively with the y. And you can see that's how they decided to do it here. They decided to do it that we're moving from right to left. Okay, so our x is our negative. So we do have a negative slope of negative 2. Example 2. The pitch of a roof refers to the slope of the roof line. Right there, the slope of the roof line. So this is a roof to a house, I guess. And this is a wall here. This is the top of the roof. Choose 2 points on the roof and find the pitch of the roof shown. Then verify that the pitch is the same by choosing a different set of points. Okay, so we're essentially going to find the difference first. And you can see that they're doing that. They're choosing 2 y's. Okay, so y2 minus y1 equals x2 minus x1. This is called delta when you find the difference. So essentially, where do you get this y1, y2? You get them from the coordinates. Okay, so if I zoom in here and I get my coordinates first, so I label them. And I've got, for u, I've got 2 and 3. Okay, so u is 2, 3. T is 0. It doesn't move left to right, but 2. So it's 0, 2. Okay, and then when we go up here to S, we get 1, 2, 3, 4, 5, 6, 7, 8. I have a run of 8. and a rise of 1, 2, 3, 4, 5, 6. Okay. Over here, it goes up by from 8, it goes to 9, 10, 11, 12. So 12 for R, and a rise, and the difference of a rise of another 2, so 8. Okay, so those are my coordinates for T, U, S, R. Okay, right there. And this is where you're going to get your y1 minus y2 and so on. And we can do that right here. And you can designate, if you designate these to be your 2's, these could be your 1's. So this could be your 2's and these could be your 1's. Just make sure you always keep them the same. So this could be my x1, y1, oops, y1, and this could be my x2, y2. Right now I'm going to go ahead and replace my variables with those. Or let's see if they chose that. No, they didn't choose those. They chose the other ones up here. Okay? They chose this set. Okay, as you can see. So when they do that, let me show you what we have here. They decided to make the 8 and the 12 the 1's. Sorry, the 2's. So these are the 2's. Okay? x2, y2, x1, y1. You can see that here. Okay? And then they subtract, and then you can see that they found a slope of a half, or 1 over 2. So that's just saying that when you rise 2, you run 4. See? 1, 2, 3, 4 is my run, and rise 2, 1, 2. That's the slope. Now, I know that these are not new concepts. We have seen these in other courses, as well as earlier on this year in this course, in course 3. So make sure that if you are feeling a little lost, to pause the video and take time to read through this on your own. And if you think you got it, go ahead, pause the video and try this one on your own. Okay, pause now. Okay, I hope you paused the video. Now, remember what we did. We did delta to find the slope, right? Let's read the question first. The plans for a teeter-totter are shown at the right using points G and L. G and L. There we go. Just going to choose those two here and here. Okay. Find the slope of the teeter-totter. Then verify that the slope is the same at a different location by choosing a different set of points. You could do it twice. Essentially, they're asking you to do delta twice, but you don't have to, because once you know how to do it once, you've proven that you know how to do it. And 2, you can see that all the points are on a line. So this is a linear function. Okay, so all of these points are going to have the same slope. But let's just go ahead and check by finding the coordinates. G has 1 and 1. Okay, 1 and 1 are those coordinates. And L has, let me count, 1, 2, 3, 4, 5, 6, 7. So a run of 7 and a rise of 3. So rise of, well, let's just put 7, 3, right? So I go ahead, I'm going to label these. These will be my 1's, x1, y1, x2, y2, right? And I'm going to go ahead and write my delta. So delta looks like this, by the way. Delta, which just means, sorry, that's supposed to be a triangle. Change in y over change in x. So we have change in y, which is y2, minus y1. We're going to find the difference in the y's, and we're going to find the difference in the x. x2 minus x1. Okay? Now I can go ahead and replace my variables, because I've already labeled them. And when I do so, it looks like this. I get 3 minus 1, 7 minus 1, because x2 minus x1 on the bottom, and y2 minus y1 on the top. Okay? Rise over run. And I get 3 minus 1 is 2, and 7 minus 1 is 6, which is 2 over 6, which is the same thing as saying 1 over 3. So for every time I rise 1, I run 3. Let's see. Run 3, 1, 2, 3, run 1, rise 1. Run 3, 1, 2, 3, rise 1. Run 3, 1, 2, 3, rise 1. And you see it. Run, rise over run. And there's your slope. Your slope is 1/3. And as always, here's your guided practice. This is how we will begin class, so make sure you feel comfortable with the content. Read through it. If you don't understand what they're asking you to do, go back to the examples in the videos. And if you still don't get it, then please bring your questions to class. See you then, everyone.